Hello? Hello? Can you hear me? Well, I sure hope so. All right, well, it's Mr. Pouts here, and I'm gonna work on section 3.7 here with you. The second part of 3.7, and what we'll say this is for this video is 3.7B, and it's all about the second part, absolute value inequalities, not equations. We did equations last time. We're gonna solve absolute value inequalities. So we're continuing with the same goal, which involves both equations and inequalities. So why don't we just recap quickly what it was with equations. So first of all, absolute value. Well, absolute value we should know by now is the distance number is from 0. So if you look at a number line, how far away is the number from 0? So that means it's always going to be a positive number, because even if it's negative 13, it's 13 spots away from 0. So the answer would be positive 13. And two examples here. The absolute value of 22 is 22 spots away from 0, so it would be 22. The absolute value of negative 22 is also 22, because it's 22 spots from 0. Now, what we focused on yesterday was solving equations like this, that were absolute value equations, where you have, like for this one, it was x plus 2, or absolute value of x plus 2 is equal to 9. We want to get the absolute value part by itself, so we're going to subtract 2 from both sides. You have absolute value of x equals 9 minus 2, which is 7, because this cancels out. So the absolute value of x is 7. That means if whatever x is, so what two numbers, if you take the absolute value of them, could be equal to 7? Well, it could be 7 or negative 7, because the absolute value of negative 7 is also 7. And to check that, when it says check your solutions, we won't graph them right now, but to check that, you plug it back in. So we do 7 is the absolute value of 7 plus 2 equal to 9. Well, this would be 7 plus 2, and that would be 9 equals 9, so that is good. All right, the other check would be at negative 7. We want to know if that would be equal to 9. Well, the absolute value of negative 7 is positive 7. It's 7 places away from 0. And that would be 9 equals 9 again. So yes, that is correct. Now what we're going to do today is deal with absolute value inequalities. Or sorry, absolute value inequalities. Maybe I should stress the inequalities part, because we're not just dealing with equations, we're going to have inequalities. So here's a key concept that I'd like you to see when you're solving absolute value inequalities. So it says here, and the highlighted parts are the most important parts. To solve an inequality in the form the absolute value of whatever is less than b, so a is the variable expression, b has to be greater than 0, it can't be negative. Solve the compound inequality as an and. Okay, so you put that in the middle, you have your less than signs, and negative b and positive b on the left and the right. So this would be like an and inequality. So less than, and actually less than or equal to would be and inequalities. When you have greater than or equal to would be the same in this form. So you have, it's just a sign that's different. Solve the inequality as an or. So greater than and greater than or equal to would be or inequalities. And it's important how it's written. You put whatever is in the middle or inside of the absolute value, and it'd be less than the negative b or greater than the positive b. And again, this just says it works for the when you have or equal to. So let's go through an example that'll be easier for you here to see the example. So it is solved for the absolute value part. So that means if we have a greater than or equal to sign, it's going to be an or, so the second one. So we're going to take the 8n out of there and say it's less than negative 24, or that 8n must be greater than, actually these are equal to, less than or equal to, greater than or equal to positive 24. And then you can solve them and graph them. So, divide both sides by 8. So n is less than or equal to negative 3, or, divide this by 8, divide this by 8, n is greater than or equal to positive 3. Okay, when we graph that, got to have 0 in here. We have positive 3, negative 3. I'm going to graph it with a different color here. So less than or equal to negative 3. So close circle at negative 3 going backwards. Greater than or equal to positive 3. It looks like that. And there's the graph. There's your solutions to your inequalities, or this inequality. All right, let's do another one. What are the solutions? Let's try this one. To this inequality. So we have it solved for the absolute value part. So let's take that out and say 2x, and it's a greater than again. So we're going to do the same thing. It's going to be an or. 2x plus 4 is less than or equal to the negative of that b, or 2x plus 4 would be greater than or equal to the positive. All right? And we just solve it. Take our steps and solve it one step at a time. Subtract 4. 2x is less than or equal to negative 9. So we have x is less than or equal to negative 4.5. Or, whoops, since we're dealing with a positive here, it's 5 minus 4, which is going to be 1. X is greater than or equal to 1/2, or 0.5. So there's our inequality. And let's graph it. So gotta have, we'll put a 0 on there. Gotta have 1. Well, we'll say this is 0.5. And we'll go all the way over here. This is negative 4.5. I'm not going to fill in the rest right now, but less than or equal to negative 4.5 would be going like that. Sorry. Greater than or equal to negative 4.5 would be like that. So there's the graph. Now, one more situation that might happen. You might end up with a word problem. So, this word problem says, a company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights for the box of crackers? So, let's set it up. It says you can be, the difference between the actual and what weights and what you want it to be can be at most 5 grams. It can't be any more off than 5 grams. So if you write that out, we'll make W the variable, and let's write the inequality. Whatever W is would be the actual weight minus the expected weight, and that difference, we just want it to be positive right now, has to be at most 5 grams. So it has to be 5 grams or less, so less than or equal to 5 grams, and there's the inequality. Now we take it like we did before. All right, this is a less than or equal to. So it's going to be an and situation. So we have W minus 213. We have less than or equal to, less than or equal to. The negative 5 is going to be over there, and then we'll keep the positive 5 over there. And when you add 213 to all three sides, again, this is different because, I don't know why that keeps happening, because of the signs, less than or equal to now. And our rules up here said, if it's less than or equal to, it's going to be an and situation. So we have W in the middle, less than or equal to 218, and this would be, sorry, 13, 208. And that is the inequality. That means that our weights can be anywhere between 208 and 218, and they can include 208 and 218. So that's our lesson on 3.7B, which is all about absolute value inequalities. Make sure if you have any questions, write them down and ask me next time you see me in class. Otherwise, have a great rest of your day.